Okay. So I think we can start, right? So we already lost a few minutes. Okay, so first, before continuing, we are in the second week. Always check the schedule, okay? There you will find what we are going to do in the week and possibly in the next weeks, okay? For the moment, we have the second week. So today there's the lecture. Tomorrow there is a lab, okay? It's divided into 3 groups, 1, 2, 3, 2 on Tuesday, so tomorrow, and the other on Thursday, okay? As I told to somebody of you before starting, I mean, there's a division, subdivision of into groups, which is in the website as well. Okay, on the basis of last name's first letter, okay? This is just something, an indication, okay? So if you really cannot come at a certain time, just feel free to come at another time. I hope there will be enough room in the room, okay? If there are any problems, we will see what to do, okay? Tomorrow's lab is very easy. I mean, just, it's already online, by the way, okay? Don't forget to check, okay, the material from the schedule, and so, oh no, this is the solution. The solution is not yet. Okay, so in the material, you'll find the labs. So very easy, getting started. So just make sure the development environment works and develop something very simple, and then start with the exercise that we are going to carry on in the next labs. Okay, so this is pure JavaScript, so just JavaScript programming, very, very easy stuff. Okay, okay, so for today, we're going to discuss about callbacks, functional programming, this keyword, a lot of things, but they are quite short. So modules, dates, and then an exercise, the third exercise that we left behind on Thursday last week. Okay, and then that's all for today. And so you have all the elements needed for the lab for tomorrow. Okay, especially a little bit of how to program with objects and this keyword and so on, if you would like to try them in the lab. Okay? Okay, so let's start. If you have questions, feel free to ask. Otherwise, we are going to talk about callbacks, which are a very, very important topic in JavaScript. Okay? Yeah, I didn't start from the beginning. Anyway, callbacks and functional programming. Callbacks are just another name for functions in JavaScript. Last time we saw functions, okay? A callback is just a name that we give a function when it has a certain role in our programming system, okay? So a callback function is just a function that is passed as a parameter to another function to be called later, okay, when the function executes, okay? There are 2 types of callbacks, which actually are just one type for JavaScript. They are just functions. But just for understanding, just for us, we would like to distinguish callbacks into asynchronous and asynchronous callbacks, okay? So synchronous callbacks, you call them and you wait for the result. Asynchronous, you call them and you will be called later when the computation has finished, okay? That's a basic difference, okay? So you see here an example, function, log quote. So actually a callback is a function, so we define it as any other function, with the function keyword, with the arrow syntax, any way you like, okay? And then you use it. How do you use it? You use it by passing it as a parameter, okay? Of course, to a function that expects as a parameter a function, otherwise it would be useless, right? Okay, so this function that receives a function as a parameter that we like to call it callback will be calling the callback later on in its code, okay, at a certain point, depending on the logic of the function. How do you call it? In JavaScript, functions are just references. So you use the variable that contains the reference, you open the round brackets, and you call it. okay? As you would do, by the way, in many other programming languages, okay? And then this is just a function. It's called, it's synchronous, very, very simple, okay? So you'll wait for the execution of the function, like when you call another function in normal programming environments, I would say, okay? So first, we are going to talk today just about synchronous callbacks. Asynchronous callbacks are more complex, much more powerful, but they are the topic for next lectures, okay? For today, synchronous callbacks are enough, and they are very much used in JavaScript, especially in this functional programming paradigm that we are going to see in a few minutes, okay? By the way, we already saw some callbacks. I didn't call them callbacks last week, but actually they are callbacks, okay? You remember we saw the sort function. We wanted to sort something. We passed a function. Passing a function, a synchronous function, like in this case, is just passing a callback. So this return A minus B is just a callback that we passed to the sort function. Sort function can take no parameters or one parameter that is a callback. It's a synchronous callback. Why? Because the sort, every time it needs to make a comparison, it calls our function, the one we passed, in this case here, return A minus B, and it waits for the result, okay? So it doesn't suspend the execution and the JavaScript does something else, okay? Just wait for the result. As in any, let's say, environment that we are used to, okay? Without asynchronous programming. So, you know, you call a function and you wait for the result, okay? The function can call other function and so on, and then back on the stack until you come back to the point where you started the call, okay? Okay. So, sort order, we already saw it in the example, just be careful in JavaScript, okay? Actually, there's no difference between the left and the right, okay? When there is a difference with the arrow function, we will point it out, but it's a very, very peculiar case, basically with the this, later today we will point out. Synchronous callbacks, for instance, you can pass it to many other functions that are available in the standard JavaScript library. For instance, arrays have a lot of functions that can get callbacks to perform operations. Actually, we already did it again last week. You remember the filter function? No, find index function was. It was in the example. Here it's a filter, okay? Instead of coding something, some code that says, should we keep the element or not in the array, you can just pass a callback. The callback returns true or false. In the case of the sort, it returns positive, 0, or negative values. Okay? Of course, what the callback should do is defined by the function that we are going to call. So if you are unsure, you just go into the documentation, like here. Market is an array. It has a filter method. We call it method because it's a property that is a reference to a function. It's already been defined by JavaScript when we created the array. A filter, what does it take? It takes a callback. What's the meaning of this callback? Well, actually, I don't really know. I need to search it in the documentation. So you go to the browser. We say the first thing you should look at, apart ChatGPT, okay, MDN, Mozilla Developer Network, okay. I would like an authoritative answer, something official, not just, you know, AI guessing, okay, even though it's probably quite good in these things. Array filter, okay, and you see what the filter expects. A callback function to be executed for each element in the array. It should return a true value to keep the element in the resulting array and false otherwise. Okay? Very simple. You pass a function that evaluates each element, and this function returns true if you want to keep the element and vice versa. Okay? Note that since you pass functions, these functions might take parameters. Okay? And which parameters do they take? Well, it depends on the one who wrote the filter function, because it's a filter function that is using the callback, and it's the filter function that is calling the callback, okay? So it's a filter function that decides which parameters should be passed to the callback, okay? So it has to be part of the documentation, and indeed it's here. You see, the first parameter is the element that is being currently processed. The second is the index, starting from 0, and the third is the whole array, so the reference to the array. So you're free to do whatever you want in your callback, and you know that you get these 3 parameters. Okay, so let's go back to the slides, and you see the example. There's a function. Actually, it takes just 1 parameter. You remember what we said last week? I mean, this is JavaScript. You can call a function, you can define a function taking 1 parameter and use it in a place where you pass 3 parameters. What happens? Simply, what is not defined or used, it's undefined. Okay? It doesn't give you an error. Okay? Just remember this. So, in short, you declare only what you need. Stock here is the element of the array, and you can use it as you think it's appropriate. In this case, we want to filter and get only the elements that have the value var, it's a variation, I guess, less than 0, okay? So stock, it's every time it's a different element of the array. So in this case, it's an object, okay, user-defined object. And so you can use the syntax that you think it works in your case for the object, like accessing a property, in this case, var, okay? You can test this code, okay? We will do it with a more complex example, not to waste too much time. Again, of course, greater than 0 and so on, okay? You see here commented the result. You just need to play a little bit. Tomorrow and Thursday for the third group, that's the moment in which you can play by yourself in the lab for these things, if you wish, okay? Okay, good. So, we introduced the synchronous callbacks, and now let's try to make a more general discussion about how to use the synchronous callback in a framework which is called functional programming, okay? Functional programming actually is a programming paradigm which is independent from JavaScript. It's like imperative programming. When you started learning computer science and you start learning programming, you started from the imperative programming, which is the easiest one, right? Define a variable, define a second variable, make the sum, print a result, one instruction after the other. That's the paradigm, the imperative programming paradigm, okay? Functional programming paradigm is a different approach, okay? Is to construct code, structured code using functions, okay? So, why we are talking about this? Because JavaScript, with this approach to functions, is very, very well suited for the functional programming paradigm, at least for certain things, like processing arrays, for instance. And we will process a lot of arrays, especially when we will develop later web applications. Okay, in React, we have elements to show and so on, and it's very, very well suited. Okay, you can write very compact code, very expressive code with this functional programming paradigm, okay? It's more declarative style rather than imperative style. So, in short, you will see you will see no loops, okay, in this declarative style of functional programming, because you write something like this on the left, as we just saw, okay? Array dot something, that is a method. You pass callbacks, and this callbacks tells the method what you want to do on the array, okay? Traditional programming is the one on the right, okay, imperative style. You define an empty array because you want a new array, and then you iterate over the elements of the array, and you run the logic of your code on each element of the array, and then if the logic of your code say to keep the element, of course, you add it to the new array. New array push, add at the end of the array, okay? So basically, you see the filter function is still here. Here, you just pass the function, and then the filter will call it for you. Here, you write it yourself, so you have to call it yourself, okay? Filter function, and you need to pass each single element, you need to iterate over the arrays and so on, okay? You prefer the left or the right? I'm not sure, okay? Maybe you're more used to the right, but at the end of this course, you will find that the left part is more convenient, okay? Also convenient is very, very useful in our programming context, okay? Because you need to write less instructions, and you can read it, and it's quite easy to read and quite easy to understand what's going on. Okay, these are some features of the functional programming. So, of course, we need to be able to pass functions around, and that's why we call callbacks. And in this case, they are synchronous callbacks, okay? We need to handle a lot of functions. We have a function like the one, the filter on the array, we pass another function, so there will be higher order functions, that the function that operates on functions takes function, maybe even return a function, and so on, okay? And of course, it compose functions. You will see an example in a minute. We will be able to make complex operations using different functions all together applied to the same element, okay? And to make everything work correctly, the basic idea here is that every time you use this functional programming paradigm on a certain structure, like the array before, you need to return a new version of the structure, so a new array, as we did before, okay? So that you can chain a second operation, a third operation, until you get your final result of what you would like to get from your code, okay? So I don't want to spend too much time on this because this is more the philosophy of the system, okay? And we are more interested in practical things, right? And the fact that JavaScript supports the features of the functional programming paradigm out of the box is very good news for us. And the thing I would like you to note is that you need to avoid mutability. That means avoid changing objects in place, okay? So in short, every time you should return a new version of the object of the array that you're processing, okay? Because that's the way in which it works best. Okay, so these are the most important methods that we have and then we will use in this functional programming paradigms in JavaScript, okay? And we will see each one of them now, okay? And then a final example summarizing the whole thing. For each, well, actually it doesn't, I mean, we start with something that doesn't actually return a new array. But basically, just to tell you, it's sort of iteration over the array, and you apply a function, you can run a function for each element of the array. Okay? Process each element with callback f. So this f, each f is a synchronous callback that we pass to the library functions, in this case operating over the array. So every f, check if whether all or some elements in the array satisfy the condition expressed by the function. Of course, in this case, the function should return a Boolean value. And if it's not, JavaScript will convert it, because the way in which every and some has been written, okay? And the more important ones, the filter, we already saw it, and the map. Map is very important. You will use the map a lot. It constructs a new array, and it creates a new element for each old element in the old array by running this f, which takes the old element, and it gives you back, it returns the new element. Okay? And finally, there is this reduce to progressively computer reduce, but I mean, this is another story. There's an example later. It's better to see the example. So for each is a sort of for of, okay? For each letter, uppercase plus equal letter to uppercase means, well, it takes each letter, okay, of the array. So for each exists on the arrays, okay, not on the strings. That's why we are converting a string into array. You remember the three dots It's a spread and creates an array with the content of what we put on the right of the 3 dots. And you see, that's more or less a for off, okay? And for each invokes your synchronous callback function one time for each element of an iterable object, okay? So in this case, the array. And then, actually, in the for each callback, you can do whatever you want. So I don't like it that much. We have put it in the functional programming paradigm, but I mean, there are side effects, right? Like this empty string that then becomes full of letters and so on. Okay, but I mean, just to give you a complete view of what is can be considered functional programming paradigm on arrays in JavaScript, we have put this example here as well. Okay, there's nothing wrong in doing for off. Okay, I would say maybe sometimes in this case might be even be more readable, but you know, it's up to you here. Okay, the callback may have 3 parameters. Actually, it's very common. You already saw it with the filter. The current value, so the element, okay? The index, which sometimes is useful because you need to filter on the index, like searching all the even position or odd position elements. You need the index, not the value, okay? And the array, because sometimes, for instance, you need the length of the array. And if you don't have the array, it's difficult to pass and to have the length of the array in the callback, okay? Because you are not calling the callback. It's the library's function that is calling the callback. So the for each, the filter, and so on, okay? This is not chainable because it returns undefined, and so in short, it doesn't return a new array, okay? And also, there's no way to stop it, and etc. So, I mean, we see it just for completeness, okay? So not really maybe so recommended. Every, okay, takes the same 3 arguments as the for each. I mean, the callback that we pass to the every. Of course, we can ignore the rest of the elements, the parameters, sorry. So the first one is always the element of the array, okay? And so it returns a Boolean value. It's supposed to return a Boolean value. It will be converted into Boolean in any case. And if it's true, it means that it checks if all elements in the array have the value true, okay? And so if all the elements have the value true, it returns you true. Otherwise, it returns false, okay? It checks the condition on all the elements, every. And sum is the opposite. It checks if at least one element satisfies the condition, okay? So it's like doing a for and check if every element satisfies the condition. And you have a flag, and in the end, if the flag didn't change, it's true. Here, if you find something that doesn't satisfy the condition, you break and you stop the execution of the for, and you tell, well, there's something that doesn't satisfy the condition, okay? Let's come to the map, which is probably the most important, and for sure the one you will use most. Because map is a way to map, indeed, an array with some content on another array with a different content, a processed content. Same number of elements, okay? And the callback that you pass should return, I would say, return a value, okay? The value is the one that will be taken and put into the new array that is created by the map, okay? Map always return a new array containing the values returned by the callback, okay? So 1, 2, 3, map, the synchronous callback is return the squared value of the number. So map will go through the iterable, so the array, and it will take the first element, it passes the first element, 1 times 1 equal to 1, is put into the result array. Then it goes to the second, 2, passed to the callback computes the result, 2 times 2, 4, it gives back 4, and the map takes the 4 and put it into the second position, 1, 4, 9, and so on. Okay? So the result value has the same length, I mean the result array has the same length of the input array. Actually, not really the input, the one on which map is called. Okay? It's not a parameter, it's just a method called on the array. You can do it with any iterable element, iterable object, I would say. Basically, in short, it means arrays for us are always safe. Okay? And you can do it for strings as well, for instance, and so on. Okay? We will see examples of this. Okay? Filter, we already saw the filter. Filters creates a new array which is might be shorter than the original one, because if the condition expressed by the callback evaluates to false, the element is not put into the resulting array. Okay? So if it's true for everything, of course, you have the same number of elements. Okay? And actually the exact same elements, because the filter doesn't do any operation. It just checks if the condition is true, it takes the element, otherwise it discards the element. Okay? It's a filter indeed. You see here an example where we use the second parameter. Okay? Like filter and take all the odd position elements in the array. So the first, the third, and the fifth position. Okay? Just remember the fact that the index starts from 0. Okay? So index percentage 2 means the rest of the division by 2. Okay? So if it's an even position, it means that condition is true and the element is taken. Otherwise, it's skipped. Okay? So 5 is taken, 3 is taken, and 1 is taken, because it's the position number index 0, index 2, index 4. Okay? And in this case, we need to declare element even if we don't use it, because the mapping for the functions, for the parameters in the function is just made on the position, okay? Not on the name. You pass values, and the first parameter maps on the first parameter, the second on the second parameter, and so on, regardless of the name you use it. Indeed, we don't know the names that have been used in the filter function. Okay? Just the first one, we know it's the element, and the second one is the index, and the third one is the reference to the array. Okay. Let's come to the last one, reduce. Okay? You might have heard about map reduce operations. Okay? And indeed, it's a functional programming paradigm. You map what you need to do on some computation instances or whatever, and then at the end you take the results and you reduce the result in a single result. Okay? The result comes from many computational instances, and you reduce it to a single value. Okay? And that's the idea of the reduce. Okay? Reduce is a bit more complex. You see, it takes a callback that takes an accumulator value as a parameter, and a current value of the array, which is not in the first position this time, but it's in the second position, and then index an array just in case. They are optional. Okay? And second parameter of the reduce is the initial value. Okay? So it combines the elements of an array using the specified function, so the callback, to produce a single value. Okay? Here it's called inject and fold, but okay, map reduces. Okay? No, I mean inject and fold is just a reduce. Okay? Map reduces the way in which you do complex computation. Okay, let's see the example so it's easier. Okay? Let's take a function that does the sum. Okay? So you see this callback, the one starting here, okay, from the second round bracket. It takes an accumulator and current value, and the result is accumulator plus current value. Okay? The initial value that we would like to give to the accumulator is here. It's the second parameter of the reduce, 0, of course. We would like to have the sum of all the elements of the array. Okay? So 0, and then 0 is put into an accumulator, which is inside the reduce function. And the reduce function keeps this number, and this number is passed the first time to our callback. So the first time the callback is called with 0 and the current value 5. Okay? And it returns 0 plus 5, 5. And then the reduce takes this 5, which is the return value, and puts it into its accumulator. And then the accumulator is used again. 5 here passed to our callback function. 4 is the new element. It returns 9. 9 is put into the accumulator. The accumulator is passed to our function. 9 with a 3. And you get 12, and so on. And you arrive at the end of the array. Okay? At the end of the array, the accumulator has a certain value, and the reduce returns the value of the accumulator. Okay? And in this case, it's 15, I think. Yes. Okay? And of course, this looks like a complicated thing to do a simple thing, right? 4 and a sum. Okay? That's the functional programming paradigm for this specific case. Okay? And note that the callback can be also more complex, like you can do, for instance, the multiplication. Of course, you need to have initial value 1, okay? Otherwise, the result is always 0. 1 times 5, 5, 5 times 4, 20, and so on. Or even you can have not arithmetic operation, okay? So if the accumulator is greater than the value, return the accumulator, otherwise the value. And this computes the maximum, because it depends on how you start. I think reduce start. I'm not sure what's the default value of the accumulator for the reduce if you don't pass it. I think it's undefined, but let's check. Okay, reduce. I'm not sure. Callback initial value optional. If it is not specified, no. Accumulator is initialized to the first value in the array. Okay, sorry, it was not undefined. Okay, it's the first value of the array if we don't pass it. Or if we pass it, as we should do here, 0 and 1. Okay, that is the initial value of the accumulator. Okay, maybe it was written here, but I didn't see it. Okay. Anyway, so almost done with the functional programming paradigm. This is just a summary. Okay. Let's have a look at this example. That's an array, a complex array. Okay, an array that contains a lot of objects, all similar objects that we define by ourselves. It's a set of vehicles where there is the manufacturer, the model, the type, and the price. Okay, there are 4 properties in each object. Okay, and we would like to know the average price, I think. Yes. Okay. How can we compute this using the functional programming paradigm? So with the method that we just saw, well, first, we isolate from the object the element that we would like to process, the price. Okay? See. Oh, no, sorry. Just for the SUV. Okay? So we would like to have the price, average price of all SUV, not all the vehicles. Okay? So first we filter. V is just a letter that we decide. It's just a name of a variable, of parameter of the callback that we pass to filter. Okay? So it can be anything. Arrow function, v type equal to SUV. Okay? So here, after this step, we have an array that is just contains elements in the array for which type is equal to SUV. And then we have the map. Map takes these objects, just less objects, and just isolate the price, as I was saying before. Okay? Because it creates a new array for which the result value of our callback, which is just the price, is put as a single element in the array. And then we do the reduce, so we do the computation. Okay? So we could do just the sum and divide afterwards, or maybe this is just a trick, but I mean, just for show you something, to show you something. So sum is the accumulator, you remember, the accumulator that we saw before. Price is the element, I is the index in the array, and array is the reference to the array. So the one that on which the reduce is called, which is not shown here because it's the result of the previous two operations. Okay? That's why it's so important to have it here as well. And so we do sum plus the price, and this computes the sum. And since we would like to have the average, we use like a trick. And so instead of summing the price and divided at the end, we sum each price divided by the length of the array. So you see why the array might be useful to have it here in the list of the parameters. And of course, we are not using the index here because it's not needed simply. Okay? Let's try the example. So you remember last time we had the VS Code. So week 02, I've already put some files online. Yeah, I wanted to show it to you. Labs code, no, labs code is labs. You always find it from the schedule, which is the simplest way of finding things. Functional programming example basically leads you to week, the correct week. Okay. Example vehicles. Okay. And that's the example that we saw on the slides. Just because copy pasting from the slides sometimes gives you extra characters and so on, we have not so much time here to test the operation, the results. Okay, so we move in week 02, and we run it. Node example vehicles. Okay. Okay, not so nice. I mean, of course, that's the result, but I wanted to show you. I mean, just that's for late. Learn to debug a little bit. And debugging here means, in short, I mean, let's try to, print what comes out. For instance, if you don't do the reduce operation. Okay? These are the 5 numbers. Okay, of the array here out after the map. Okay, oops. You want to see what happens after the filter? Remember to say the 5. Right? These are just the 5 lines. I mean 5 objects which have the type equal to SUV. Okay. You can just play a little bit with the code. Okay. Especially tomorrow in the lab, just to familiarize with the environment, with JavaScript and so on. Okay? That's why I've put this example online, just to, see what happens. Okay? Or maybe you want to do the average afterwards. Just play and try to do the sum. Okay? Instead of the average, of course, later on you should divide, okay, to get the average, okay? Just to see what happens. You see, in this case, I and array are not used. That's why the Visual Studio Code changed the color of the variable, okay? But, I mean, this is just to help programming faster, okay? Okay, we're not saving this file, I mean, just for playing. Okay, good. So, we still have some time before the break. Okay, so we'll go through a few quick topics in JavaScript that are anyway useful for, to know what is needed for us to program web applications. I mean, in this course at least. So now we have a look at this keyword. Okay. There are a few slides, but the message is quite simple. And the message could be summarized in, I mean, this doesn't work as you expect, not always at least, in JavaScript. Okay? The this keyword, of course, you have the this in many other object-oriented programming languages because it's the keyword that refers to the current object. Right? Very simple. But you know that functions in JavaScript are quite special. There is no object-oriented programming paradigm, actually, not in the traditional way for which we are used to think. There are no private properties and so on. Okay? So, this behaves in a little peculiar way in JavaScript. Okay? This does not and so on, but I mean, it doesn't really work. It's not worth reading this description. Let's see, you know, what we should remember. Well, in each function, the this is always bound to some specific object. Okay? And to which object? Well, it depends on what I did before. In particular, what I did when I called the function. Okay? So the binding of this means what the this refers to depends exclusively on the call site of the function. No, not on how you declare the function, not where the function is declared, and so on, except for arrow functions, which are seen at the end of this set of slides. So what is the call site of the function? Well, at this stage in computer engineering, you probably know, okay? But just, you know, to make sure we are on the same page, if you are in a function, you just go back one step in the stack where functions are called, and that location is the true call site of the function, okay? The same function might be called from different places, okay? So it means that the this might have different values depending on where the function is called. And that's a difficulty, okay? Because in let's say, traditional object-oriented programming, typically, what's the value of this depends on how you coded the function, not where you called the function, okay? That's the real difference for JavaScript, okay? So the call site of the invocation of this function that uses the this is the only important information we should have. Oops. Okay, so see the example. Bus it's a function that then calls bar, that calls foo, etc. Okay? There's a call stack. You go back one step and you find the call site of the function. Okay? But this is quite easy, I mean, to guess at your level in computer engineering, I would say. Okay? There is even this sort of simulator you can play a little bit. The links in the slides are always clickable, except, I mean, if you browse them from the GitHub, they don't work. But if you download the slides, they work. Okay? So let's try just to see. Okay? Okay, this guy is the one who developed the simulator. But, I mean, save and run, I think. Buzz then call bar calls foo does something, and then you go back and you empty the stack when you return from a function. Okay? So this is called indeed call stack. You go one step below in the call stack, you have the call site for the function. Okay? So like rerun and then we make pause. Okay, foo. So where should I search the call place for foo? I go one step below. It was in bar. Okay, bar, and foo is called here. Okay, so this is the line, okay, that calls foo, and this is the call site, and the only place I should look for when I need to know what's the value of this in foo. Okay. Okay, good. So 4 rules, 2 are less important, 2 are more important. The first one is good, is important, I mean, it's the default binding. So this, okay, we call the function, let's say, I would say normally, not on an object, okay? Normal function call. I define a function, I call a function, okay? This is undefined. Very simple. You cannot use this. That's all. When not in strict mode, this is the global object. So the global object in Node.js, window in the browser, so difficult, so messy, so error prone. That's why we don't want to use the JavaScript code outside the strict mode. Okay? So confusing. Let's avoid using JavaScript outside the strict mode. So simply, this is undefined. So this dot something will give you an error. Okay? Because you cannot use the dot on undefined. Okay? So also easy to catch when you debug. Okay? So in short, it's useless. Okay? So when your functions are called alone, it's useless. Don't use it. Very simple. Rule number 1, don't use it. Okay, rule number 2, implicit binding. Okay, you call a function on an object. So like if the function is the method of an object, okay, this time inside foo, this refers to the object. It's more or less what you would expect in normal object-oriented programming. Okay, you call a method on an object, and with the this, you can access other properties, other elements of the same object. Okay, just remember here, we have objects, we don't have classes, we don't have the templates, and so on. Okay, indeed, you must be careful. Okay, because it depends on where you call the function. Okay, object a foo. Okay, object foo called on object. Okay, as the this refer to the object. So this a works here. But if we call it as foo without object dot, okay, well, we cannot do it here, but I mean, let's make a copy. I think that's, yes, that's a more complex example, but anyway. So you see here, object foo, the previous one, right? Object foo, you assign to bar, you call bar, this doesn't work anymore because the only thing JavaScript cares about is the call site of the function. Okay, how it is called. So you lost the reference to the object. You still have the reference to the function. Of course, you must be able to call the function, of course, but this will not work. This dot a, okay, this will be undefined because for the first rule we said before, if you call a function alone, the this is undefined. Okay, even if it came from object.foo, it doesn't remember it. Okay, that's why that's how JavaScript works. Okay, it can be even more complex. Do foo, etc. You can pass around function, etc. Okay. Just be careful. In short, we can say, beware of losing the reference object. Always pass the object, never functions, when you need to pass a function that needs to be called on an object. Because if you lose the object, you lose the possibility to use the this inside the function. Okay? Because you need to call it alone, and this will be undefined. If you pass the object, maybe it's less convenient. That's why I told you using object-oriented programming in JavaScript is really up to you. Maybe it's not recommended. I would say not really recommended unless you really like object-oriented programming and you like to deal with all these problems that JavaScript, I would say, create with objects. Okay? So, in short, you really want to use the this, always pass objects and never the functions alone. okay? Because if you pass the object, you can write object.function. You have the reference to the object because the call site has the function called on an object, and this is set, okay? That's more or less what we need to know. And then there are a couple of peculiar rules we describe, 3 and 4, but I mean, explicit and new bindings, okay? Explicit bindings, basically, you have two methods on each function. Remember, a function is a JavaScript object. You have the call method and the apply method. You can attach an object to a function, okay? Temporarily or permanently, okay? In short. But typically, you don't write the code like this, okay? Libraries like to write code like this because sometimes libraries like to give you just a function to call and not the object on which you need to choose a method to call, okay? And so in this way, JavaScript has a mechanism to attach an object to a function, okay, explicitly. And so even if you call the function alone, in short, this inside the function can be used because you attached it, okay? But I mean, I would say we can forget about this because it's really unusual for our code, okay? If you are writing a JavaScript library, you can come back to this slide, okay? Okay, hard binding as well. So call, apply, and there is also a bind, okay? So one is always bound, the other is just for the call, okay? But I mean, really technical stuff we don't really need. Fourth one, and maybe the more interesting one for us, you create an object with a new keyword. What's the value of this inside the function that you use as a constructor? And that's what we are going to do in the example in the second 1 hour and a half, okay? So common, right? We write a constructor function. Actually, we already saw an example, I think. New with the constructor function. Well, this works as we expect. The this inside the constructor function is the reference to the object that will be created and returned at the end. Okay? So new, create a new object, and the this refer to the new object. Good. This is really good. Okay? And of course, a new something returns an object, and we typically assign it to a variable where we get a reference to the object that we later use it. So the new, in short, creates a brand new object, empty object. Okay, the story of the prototype is outside the scope of the course. Okay, a few years ago we used to tell this, but I mean, since we don't really want to focus on this object-oriented programming style, we can forget about this. And the newly constructed object, so this new object, is simply set the this for the call, okay? And unless you write something different in the return statement of function, you don't have to write any return. The function automatically returns the new object, okay? That's all. So in summary, the function is called with the new. Well, very easy. This refers to the newly created object. Is the function called with some method, special method, the call, apply, bind, etc.? Okay. Has been, you already did the bind before, etc. Well, if you did it, you know which object you attached. Okay, but that's a special case for the libraries and so on. We don't really care. Is the function called within a context? So it means you call it on an object? Yes. Okay. And so the function has the this that refers to the object, in this case object 1. Okay? What we call implicit binding, the rule number 2. Okay? Otherwise, rule number 1, default binding, If in strict mode, this is useless because it's undefined. Okay, and we will be always in strict mode, so you shouldn't use the this. Okay. Oh, okay. So last topic. Arrow functions. Arrow functions are not just a nice way to write functions. They are nice in the sense that you can write very compact functions. You already saw it. But there is also this peculiarity that this is treated differently. Okay? So the arrow functions have a this that adopts the binding from the enclosing function scope. So it depends on what the caller of the function did for the this. Okay? It's like that the arrow function inherits the this from the outer scope. Okay? So in short, you can use an arrow function and in a place where you typically pass it like a synchronous callback as the one that we saw this afternoon before. And you want to have the this available inside this arrow function with a certain value. It's very easy. You just have to make sure that the this is set to what you want, okay, before the arrow function is called. Okay? And the this will have a certain value that comes from the scope where the function is called. Okay? And this is very convenient in event handlers and in callbacks, for the reason I told you. Yes, that's the question.
If I understand well, this type of, the this in this case,
yes?
is preset. It's like when I have created the actual function or called the object,
Yes?
it stays the same.
It stays?
The same, it doesn't change.
Yeah, it doesn't change. It's like it's already set before calling the callback, and the callback see the this as a variable which is available in the scope, okay, and it can use it, okay, and indeed, no, what is this is a place where it's said. It's a no. Basically, it's create a closure over the this variable, okay? As it might create a closure over many other variables, okay? In this case, there are no other variables, but maybe you have, let's say, parameters, etc. You create closures on that, okay? You define it, and so you make sure that the this is accessible to the function, and when you call it, JavaScript, since it's an arrow function, will make the this available depending on the scope where the function was called. Okay? So that's the summary. Okay? So yes, default binding useless. Okay? Functions called alone, this is useless. Function called on an object, let's say sort of normal case, this refers to the object, like in the traditional object-oriented programming languages. Explicit binding, we don't use it in our programs. New binding, that is the new object, okay? And then exception, arrow functions, here it is, closure over this, okay? Uses the surrounding scope. So somebody has this set in a certain way, and this will be made available to the arrow function. Okay? If you have a traditional function instead, all the other rules apply. So you call the function not an object, this is undefined. Okay? And that's why it's so convenient to use the arrow functions in the event handler, okay? Because in this way you can set this and make it available to the function, okay? You can say, well, I could pass parameters to the to the function before calling it. Yeah, it's true, it's possible, okay? It's just a possibility, okay? Some libraries work in this way, like the one we're going to see next time, okay, for the SQLite and so on. Sometimes make things available with the this, okay? Because the this is an object, for some reasons they design it in this way, okay? Otherwise you could pass an object, but you need to pass an object, maybe you need to change the signature of the function, so the list of parameters and so on. I mean, they didn't want and they made something available with the this. So we will remark this behavior at a certain point when we discuss a library function in the context of databases. Okay, I think it's what I wanted to do for the first hour and a half, I guess. Let me check, always on the schedule. Is the schedule? Yes. And I guess we can have a break, okay, a short break. Let's try not to make it last too much, okay? Since there's no crowd outside, you should be quite fast, okay? And since we have 3 topics for the second part of the lecture, okay, maybe we can start at 2:30 sharp, okay? If you have questions, of course, I'm here. I'm glad to answer you.